Okay, so the next thing we're going to talk about is the atmosphere of the Sun, and I want to come back to this idea of spectrum. So here we have a spectrum where basically if you lay these end to end you'll get a really long detailed rainbow, and so you go from infrared through red, orange, yellow, green, blue to violet, and you have all these lines in here that are absorptions in the photosphere due to atoms that are in there, and this allows us to determine both the temperature and the composition of the Sun, and we'll come back to that after spring break. But the absorption lines come from the photosphere, but there are also emission lines on top of that, and they come from the atmosphere, and the lower atmosphere is called the chromosphere. And this term chromo comes from color, and we'll see that we get the coloring has to do with the hydrogen atoms that are in there. So we have the chromosphere. It extends a few thousand kilometers up. It has even lower density than the photosphere, and it's reddish. So, as I said, it's to do with hydrogen. Remember we talked about how you've got n equals 3 to 2. N equals 3 to 2 will give you a 656 nanometer line. If you do 4 to 2 you get green, if you do 5 to 2 you get purple, and so on. But this is a very common transition. And so you have a lot of ways you can get to this transition, and so you get a lot of nebulae that are red, and it's to do with this line. And so there's hydrogen that's in the atmosphere, and it is excited to the n equals 3 level, and then they drop down, and you can see this red color. It's hard to normally see the red because the photosphere is so bright, and that's continuum, you just don't notice it. But we have these emission lines, and we can take a spectrum of it. But here you can see that this is kind of doing a close-up on the edge. You have this fabulous flame-like pattern. You can see pieces of it here, and that's from this atmosphere of excited hydrogen. And then above the chromosphere we have a transition zone where the temperature rises very rapidly, and not much is known about that. And then we have the corona. And the corona is about 10 to the 6 Kelvin, and so hot that it's basically giving us continuum and peaking in the far ultraviolet. And we can see this over and above the black body because the 6,000 Kelvin black body of the Sun doesn't really give us much in the way of UV. Remember, it's peaking in yellow, and it drops off pretty rapidly into the UV. It does have some UV and some X-rays, but it's dropped off a lot, so you can see this ultraviolet light that's coming from this upper atmosphere. We're not going to go into it anymore for now, but we can talk about it in class. So here's kind of a summary of the Sun. We've got evidence that you have nuclear reactions. We have other evidence for the internal structure from things like granulation. So you've got the granules. We talked about optical depth in terms of having limb darkening. And then we also have why the photosphere is opaque, what gives rise to its optical depth, where different spectral lines come from. We have absorption and emission lines, and then the structure of the